So for week 4, we'll be discussing the electric field of distributed charge, and we'll be finding the electric field for uniformly charged rod, a charged ring, a charged plate, and uniformly charged spheres. In this video, I will not be discussing each individual equation for the electric fields, but instead notes that I took for some of them and special cases. So we're going to start with the electric rod on a symmetry plane. First note that I took was if the rod is positively charged, the direction of the field is going to be radially outward. However, if the rod is negatively charged, it's going to be radially inward. So just so you have a visual representation in your mind, a rod is basically like this pin, and if the observation location was on the axis and this was splitting the axis, aka on a symmetry plane, the y electric field on the y in the y axis is going to cancel out, while the x is going to be positive. That's if the rod is positive. So if it's negative, the y's will still cancel out. However, the x will be flipped. So special cases I wrote down for the rod was if the L is very large compared to the R. So R is going to represent the distance from the rod to any point in the symmetry plane, while L is the distance between the point charge and the observation location. So if the L is greater than the R, then this tells us that the electric field falls off as 1 over R. Now, if R is very large compared to L, we'll consider the rod has a point charge because of the distance between the observation location and that rod. The next electric field I will be discussing is that of the charged plate. So special cases for this was if Z is much smaller than R. So Z is much smaller than R for a charged plate. We can neglect the Z in the denominator of the electric field equation. This is because when near the plate, the electric field is essentially a constant. Another special case I wrote down for this one was if Z is much larger than R. This is kind of like the rod electric field. So if Z is much larger than R, then we'll see the charged plate as a point charge as well. The last electric field I'm going to discuss is that of charged spheres. So there are two types of spheres: a hollow sphere and a solid sphere. So note that I wrote down for this one is that the E field inside of a uniformly charged spherical shell is always 0. And that's all the notes. So for the questions, summarize the main physics ideas for this week in your own words. I just did that. I learned basically all this is basically new to me. It was fairly easy and understandable. The videos did a great job at explaining them, and the visual representations were very well also. Was there something in the lecture that really sparked your curiosity? Does it someone relate to your own area of study? I mean, I found the process for finding the electric fields of each one was pretty cool. How we break them down. Like we could use the same 3 steps for finding the electric field for every single one of them. Well, I even wrote that down. It was divide the charge object. Second, find an expression for finding the electric field of one piece of it, and then use that expression to find the electric field of the rest of the pieces and add it together for the sum to get the net electric field. I thought that was pretty cool how we can use these same 3 steps for each one. See the most confusing. I thought that they were all pretty simple. As I said, the videos did a great job at explaining them.